Good day everyone, I am Jasper Roberts and today me and Locke Morales were going to report about the principle of solubility. Dissolution is a process of a solid separating into its individual molecules or ions when immersed into a liquid, and the general rule is like dissolves like in terms of polarity of the solvent and the polarity of molecules comprising the solid. Let's take and look at the most abundant solvent here on earth, and that is water. Remember that water molecules have a strong premium dipole moment that is pointing toward oxygen atom. The water molecules has a partial positive wherein the hydrogen over, and because of strong dipole moment it is good to dissolving other polar solid or ion. When we drop a solid in the water, the ion will separate, and as separating water molecules were from them in a way to stabilize its ion. So the water molecules were dipole moments such that the portion positive charge in the water molecules will be facing current ion, and the portion negative charge, meaning the oxygen, will be facing the sodium ion. And this kind of rearrangement of the water molecules to stabilize the ion is called hydration of ions. Polar charged and charged molecules in water. The water molecules were arranged themselves and solubilize the organic and the most polar and the charged. The organic molecules, there will be long pairs, and these long pairs will form hydrogen bonds when water molecules. More generally, we can say that polar and charged organic molecules are dissolved by polar solvent.
Now, what happens when we put a non-polar chunks of solid into water like naphthalene? In this case, the water molecules don't really know what to do with the naphthalene because naphthalene does not have dipole moment. In this case, it's actually better for the naphthalene to stay together because they can interact favorably through dispersion forces, whereas the water molecules will not provide any additional stabilization for the naphthalenes to come apart and go into solutions. So more generally, we could say that nonpolar organic molecules are not dissolved by polar solvents. Now what if we throw a chunk of naphthalene into benzene? Benzene has a very similar structure to a naphthalene, so naphthalene can form dispersion forces with benzene just as we could do it with itself. So more generally, we could say that nonpolar organic molecules are dissolved by nonpolar solvent. The rule of thumb for solubility is that like dissolve like, so polar solvent will dissolve ions, polar molecules, and charged molecules, and the solubility of an organic molecule in a polar solvent will be proportional to the molecule's polarity. So the more polar the molecule, the more it will be soluble. It will be soluble in a polar solvent. Generally, do not dissolve nonpolar molecules very well. However, nonpolar solvents do dissolve nonpolar molecules, but nonpolar solvents do not dissolve ionic solids, and the more similar the structure of the solvent is to that of the solute, the better the solubility. So, how do we evaluate the polarity of a solvent? We do that by comparing the dielectric constant of the solvent. The dielectric constant is a unitless number, and it is defined as a number, and it is defined as the ratio of the capacitance through the medium interest versus the capacitance through vacuum. So here are some dielectric constant. So here are some dielectric constant for some common solvents. And you can see that water has the largest dielectric constant, and that because of how polar it is. As a solvent polar, it is a solvent, so that greater the dielectric constant of the solvent, the dielectric constant of the solvent, the greater its polarity.